Hello everyone and welcome to another video. Today we are going to try and implement enums in Hermes. If you have watched my previous videos, I have been porting curl to Hermes and I encountered a problem where I wanted to port an enum that curl has implemented into Hermes, but then I realized Hermes doesn't have enums, so I have to implement that. Um, and if you're a new watcher, Hermes is a programming language that I have been working on. So let's try and do this. Right, we have a curl branch here. I'm going to check out master actually. And yeah, this is not a tutorial. I am just inviting you here to join my journey. Okay. So it has been a long time since I actually was developing or implementing stuff in Hermes. I've taken sort of a break from it, but so we'll see how this goes, you know. But I assume I'm gonna have to add. Because basically I want to add a new. This is basically a new sort of data type or whatever you want to call it. I'm thinking I want to add it under here. So we're gonna have enum. And let's check where this is being. Whoa. Actually, let's check for. Let's check where object. Right. Because enums are always going to be integers in this implementation. I created an issue for it on GitHub, and I said that they should always be integers. I want to keep it simple. So it's actually, I mean, it's sort of gonna be, let's just create a enum.he file here to play around with how I want it to look like. So I don't want you to be able to do something like this, enum my func. I don't want you to be able to return an enum like that, I think. So you would do int, because it's going to be an integer, and then you would do return my enum var or something. But basically, I want to have this enum. Let's just do enum. Animal dog, animal horse, animal cat, something like that. And in C you can actually do like this, and I don't want you to be able to do that in Hermes, not to start with at least. Maybe I'll implement that later, but for now I want to keep it really simple. I might actually have to implement this sort of behavior as well if I want to be able to port enum stuff from C libraries correctly. Anyway, we're gonna start with this, okay? So let's just do this, print animal dog. And my expected behavior of this is going to be a 0, I think. Yeah, because I think it's gonna start 0, 1, 2. So obviously this will not, let's recompile. Obviously this will not work right now. Examples, enum.he, undefined variable enum. It thinks that I'm trying to access a variable actually. Okay, so I actually think that the enum here is sort of, it's sort of like a statement that, oh, here is enum. Or maybe it should behave like a type so you can return it. Oh, well, let's just play around with this. Okay, you are going to, if I do this, you are going to be able to return it, because this is going to parse function definition. Right, here's the type checking. So we're going to do this. Est enum. Okay, so it's sort of going to be a data type. I don't really like that, but we're going to start with that. Okay, so okay, we have to implement the enum thing as well. Let's put it. Do we have the object here somewhere? Yeah, so we're gonna do enum. Make clean make. So it compiles. I wonder if what happens if we run that now. Right. So actually, right, so it's actually not going to look exactly like in C. So actually in Hermes the syntax would be enum animal is equal to parser parse function definition. Right, so we're gonna end up in here equals no, we're gonna end up here actually. Yeah, we're gonna end up here, and then it's going to do parse expr. Okay, and then we're gonna go into, I wonder if I have my C tags generated. I want to be able to jump to the definition. Okay, I have to restart Vim. Let's put it here. It's easier to read. And let's make it a bit bigger. I mean, we could make it into a statement, I guess, to make it look more like C. Maybe that's actually... Let's start by making it like a data type, actually. Parse expr, parse object, parse. So I assume this is the parse factor, parse term, parse return, parse if. There we go. Now we can jump to definitions. Okay, parse expression, and it's gonna go up here to parse term. It's actually going to go up here into parses the object. Okay, so this is actually a parse factor. And here's where it parses the object. Parse object. So, or actually, it's going to go into the parse object function. Which isn't really what I want. Parse null, parse new, parse function call, parse factor, parse expression, parse list. So this is the parse factor method. And it's going to go into the parse. We're definitely going to end up here. It's going to go into parse object. I kind of want to skip that stage. Parse term, parse object, enum. What we could do is, if we go into this function definition, we have the type here, basically. We have the type. So one way we could do this is to switch on the type, I guess. Type. Because if we're defining something with the type of enum, then I don't really want to parse. I want to parse the enum syntax immediately. I don't care about an expression to the right of the definition, basically. So if est type value data type enum. So if the current type we're trying to do, or the current variable we're trying to define has the type enum, then we're going to do a special case here. I realized that I could do this with the other. Actually, this is a better way of handling the right side expression. I mean, if I would have done that on all types, then I wouldn't have need this type checking here, because then I would know that. Holy shit, my phone just dropped. Let's put it here so it's not gonna annoy me. Okay. So then I would do basically this. Parse enum. And obviously it doesn't have that functionality yet, so we need to add that signature here. Parse enum. And we can basically copy the parse object logic. And we want to rename this one to enum. Okay. We can actually reuse, we could reuse the, no, let's create a new children type here. So we're gonna have an object children and we're gonna have an enum children. It's actually better to separate it. Okay, so now we have that list that we can use. And we're doing this. And we're gonna parse, we're actually gonna parse variables here. Parse while Hermes parser current token type is equal to token semi. No, that's, we actually want to do token comma. Parse variable. Okay, let's compile this. I forgot to rename it here. Enum children. Oh, we need to recompile, I think. No, enum children has no member. Enum children. I thought I added it. What? AST struct has no member. Enum children. Oh, of course. Need to add it in the header file. Object children. Enum children. Cool, so it compiles. Now if I do run this, unexpected token animal dog was expecting 8. And what is 8? 0, 1, 2, 3, 4, 5, 6, 7, 8. Function call. Function definition. Oh, maybe I'm still expecting a function definition. Parser. Parse variable. Parse variable. Parse enum. Let's just see if we actually go in here. Printf parsing enum. Yeah, we are going in there. So if we are maybe it's a bad idea to parse variable actually. Parse variable. So what does this do? To simplify this a bit, let's just go into the enum.ag and remove this for now. And just to check this. Is it actually this expecting? No. Oh, it's not. This is wrong. Token.age. Unexpected. Third, fourth, fourth. Oh, it's expecting right brace. Why is that? Parser. So are we ending up here actually? What? Oh, actually, I think I know why. The parse variable doesn't automatically eat the ID. So Hermes parser eat Hermes parser token ID. If I remember correctly, this is how it works. It's difficult to work on a small screen. Segmentation fault. Okay. Well, that's pretty good actually. So why are we getting a segmentation fault? Parse statements invalid dynamic list size 33. 379. Oh, I'm doing object children. Should be enum children. There we go. It actually works now. But but now it doesn't know what to do with the enum, basically. So now we need a way to tell the interpreter what to do with the enum. What is it? Enum runtime.c. So we're going to do one for enum as well. Oh, is it enum? Okay, so now it knows how to parse the enum, so it does that fine. Now we actually need to populate these variables with values, actually. And if we go, I think what we're going to do here is actually, you're not going to be able to access it like this, like you actually do in C. You're going to have to do that, but that, I kind of like this better actually. But it doesn't know what to do it because this is just a variable. It's not a variable definition, basically. So, maybe I shouldn't do this. Maybe I should do parse variable definition. What? Oh, actually, it should be fun. Oh. Right, I don't have a single parse variable definition. It's built into the function and knows how to handle function definitions. So actually, I can't do that. I guess we can define them during runtime, but that's not very satisfying. Maybe we could create another EST called like named integer or something. But I don't really like that either. So the est.c runtime visit variable. So when we're visiting a variable, we're going to do a lookup for the definition. if it is an object, this is just ref object vardef. What am I even doing here? Vardef variable name. If I pass in an object and the children size, well, that doesn't even make sense. Attribute access. Is the string if the left one is an object. Oh, I see what's going on here. But basically, we want to copy this behavior for enums. You're not gonna be able to reassign it or modify it, and you're not gonna be able to have enums within enums. Node let's not do this. Okay. So now when we do visit variable, we're gonna have another one here, another if, else, if node enum children not equals to void. This, I don't know if, okay. And we're gonna have an if node object node enum children size /0. We can iterate through them. Then we can do variable is equal to ASTT node enum children items I. And then if string compare variable name node variable name is equal to 0. Now, one quick little hack we could do here is actually to initialize the integer and just return it. Because we have the enum value here actually, it's the I. Let me just explain a little bit here what I was doing. So this visit attribute access, it knows what to do with things like this. Hello, yo, x, y. It knows, like when you're doing dots like this next to a variable, it knows what to do with that. It knows how to access components within that variable, basically. So what I did here is that if the left of the dot is an enum and the right type is a variable, then I pass the enum children to the right one, and then actually the right one will be visited with this visit variable method, and it's gonna have the passed enum children to it. So basically, we have what we want here. Wait, this is actually good. This is sort of an optimization. You know, I could have defined the integers during the parse time so that the right, even we get to the runtime visitor, it will already know what values the enums have. But in this case, we're only defining the values if you are using them. So in some sense, this is better. So what we can do here is actually, if variable int value return variable int value, otherwise, no, actually, that's not what I want to do. We have a void object value. Let's add another here. Void random randomly accessible I don't know what I like about that name actually. Void. Let's just call it AST. Why not? Void AST. If variable AST not equals to void pointer, return variable AST, else variable AST is equal to init AST integer variable AST int value is equal to I. Return variable AST. Now one more thing to do, and it is to AST. All right, it doesn't know what it is. Let's just do it like this. AST t int AST is equal to that. AST in value is equal to I. Return in AST. And it compiles. Let's see what happens if we run it. Unexpected token animal dog. What? I thought we fixed this. What? Oh, we have something weird going here. Oh, of course. Hello, where am I? That's very strange. What? Oh, I removed the ID thing. Undefined variable, animal dog, crap. Oh, right. Visit variable. It's gonna do that. Okay, maybe we're not getting in here actually. We are getting in there. Are we getting in here? Yeah. Are we getting in here? No. Printf variable name. Okay, that's very that's not good at all. I think I know what the problem is. I have to eat the ID first. Isn't that the problem? There we go. So if we go into the enum.h, print animal dog, print animal horse. Now we should see 0, 1. Yeah. So I guess enums are implemented like they should. What happens if I print animal? I don't think it knows what to do with that actually. No. Because it doesn't have a print function for it. There we go. Can actually do this instead to make it prettier. Cool. So I wonder if I can return an enum. I know I said in the beginning after we did that I didn't want that behavior, But now I actually implemented that behavior. Anyway. Enum get animal enum. I just want to see if that works because it's interesting. Return animal. And then what if we do enum xyz is equal to get animal enum xyz. That did not work for some reason. Why? Oh. No? Right, it actually doesn't support that. Yeah, you can't actually. Here's where it's what it doesn't like. You can't define a function that returns enum actually. It's not possible. I think this is what it's complaining about. No, actually not. No, it's actually here. You can't, like I said, to the right side of the equal sign, we made a very specific assertion to parse this type of syntax here. That's what I added in the, I think I did it in the parse function diff. Yeah, this is my special case here, so that's why I am implicitly saying that I want to parse an enum. Well, that's fine, I guess. That's fine. Now there is a hack to do this actually. I think if you do void, it will not care. Yeah, so you can actually do that. Well, I have to fix that. Like the typing system in Hermes isn't extremely strict at the moment. They're basically just like hints. Now there are some kind of strictness to them. I mean, you can't do, for example, you can't do string x is equal to yo. It's gonna say a type error, I think. No, you can't actually do that. No, sorry, a string x equals 1. Yeah, invalid type for assigned value. So there's some strictness to it. Okay, but enums sort of work, or they do work. And you can actually return enums from a function. What? Unexpected token dot. Oh. All right. So what I'm gonna do now is I just wanna see if I ruined anything else. I'm gonna go into the tests. Now the proper way here would be to add a test for enums as well. But I'm not gonna do that in this video. For now I'm gonna do checkout b enums. Implements enums. And I think I created a GitHub issue for this. So we're going to come on. Implement enum. I think, yeah, implement enums. closes 27. All right, we implemented Enums. Fantastic. Now I should be able to port the curl enums as well. So I'll do that in my curl videos. But thank you so much for watching, and I hope you enjoyed the video. And if you're not already a subscriber, please click the subscribe button if you want to see more of my content. And also hit the bell button if you don't want to miss my uploads. And yeah. Thank you for watching, and I'll see you in the next video.